Thank you for the introduction and welcome. First, let me start off with a question. How many of you showered this morning? Can I get a show of hands? All right. Imagine you're waking up this morning, you're getting ready for work, you turn the tap on, and you've got no water. How would you feel? Annoyed, right? That's how I would feel. And that is the situation we don't want our customers to be in at Water Corporation. And today I'll be talking about one of the most challenging yet rewarding projects I've managed, and that is Newman Town Water Supply Upgrade Project. I hope this talk will be insightful to people in this room who wish to deliver a similar type of project within their own organizations. So, to give you a bit of background, Newman is a mining town located approximately 1,200 kilometers north of Perth with a population of around 7,000. The infrastructure was built by Mount Newman Mining Company in 1960s. Currently, the water scheme of the town is jointly operated by Water Corporation and BHP. So Water Corporation is responsible for operation and maintenance of the reticulation system, and BHP is responsible for source management and water treatment. In recent years, the scheme had a number of repeated failures due to deteriorating asset conditions. So to give you an idea, the frequency of interruptions in Newman is approximately 10 times higher than of Perth. Shocking, isn't it? Like for a town of just 7,000 people to experience such amount of interruptions. So to address this issue, WaterCorp created this project, which will improve and enhance the reliability of the water supply scheme. So the overarching scope of this project is essentially to reset and reconfigure the scheme operations so that the current issues are resolved as well as the future impacts are minimized. So the deliverables are construction of 3 magnetic flow meters so that we can accurately gauge and measure how much water we're supplying to the customers, as well as we can monitor the water data from our operations center. And construction of 3 cross connections within the town reticulation system to improve the network connectivity. Replacement of 3 47 isolation valves so that when bursts within the scheme occurs, we can minimize the customer impacts. Previously, before this project, we had a number of broken valves in town. So if there was a burst or leak, we had to shut a bigger section of town. So by replacing these valves, the customer impact will be minimized. And last but not least, replacement of above ground fire hydrants. The current standards for the above ground for the high fire hydrants are actually below ground now. So we're just pretty much bringing it back to the standard. So that will also improve the firefighting capability of the town. So this is pretty much the overview of scope on the map. As you can see, these dots represents the worksite locations, and it's all scattered over the town. And also there's some pockets of areas where we would have to impact customers multiple times. And also, most of the work sites are in public areas, so we had to manage the safety side of things, like having open excavated holes and machineries around these public areas. So I worked with both internal and external stakeholders to work out how we can actually deliver this project effectively without impacting the community. So the stakeholders were, internal stakeholders were operations, the design team, and other design consultants that we engaged. And the externals were BHP, major customers, and businesses within the town. So after a lot of discussions, we came up with this. To deliver the project in 2 different stages. So we bundled all the works that required the whole complete town supply shut into stage 1. So in stage 1, we planned for 8 hours of water supply interruption for the entire town. And we worked with multiple contractors to deliver different packages of work so that we complete within 1 hit. So 1 big shot and 1 hit. And successful completion of that stage 1 allowed us to proceed to stage 2, which only required a smaller scale shots, but still there were a lot of smaller scale shots. So the works involved in stage 1 were the construction of 3 magnetic flow meters, construction of 3 cross connections, and 5 critical valves within the reticulation system. And the remaining valves and hydrants were delivered as part of the stage 2. So during the delivery, we encountered a number of challenges. For example, excavating around the corroded steel pipes and old asbestos mains were causing bursts and planned bursts and leaks. So because of that, we had contingencies in place, but it still happened. So the contingencies we had were, like, we had a whole heap of spare parts, pipes, fittings, so that if things like that occur while we were doing work, we could actually attend to those. And Pilbara is known for its harsh environmental conditions. So working in above 40-degree heat was a challenge with the heat stress issues. So we had to actually make sure the workers take plenty of breaks while they were doing works. And we also had flash flooding from Cyclone Joyce to deal with. So, and another thing was high-level customer engagements with BHP, the local shire, and businesses. Like, for example, even to do any work in town, we had to get excavation permit, electrical corridor permit from BHP, because they pretty much run the town. And also, as our work sites are all over town in a very public areas, we had to get approval from the shire, traffic management plans, etc. And we also engaged the local businesses and mine camps and rec centers to understand their needs, and we worked around them. When we were planning for the shuts, we worked around their needs. And most of the major water disruptions were undertaken overnight, and they were all negotiated with all the major customers involved. And the last thing is the non-standard assets and installations. So we were finding a lot of different things, like massive truss blocks, concrete blocks buried underground, and also like power cables, like underground utilities. They're all really close to water mains. So back in the day, it appears to be like they've just laid everything in a single trench. So there's no like they didn't use proper boundary corridors for different utilities. So this is one example of the non-standard installation. So what you're seeing here is a section of pipe with an above-ground hydrant sticking out. Typically, so the T-piece, so typically in this arrangement, you would have a T-piece here and a smaller truss block behind the T-piece, not encased like this. And when we pulled it out, we actually checked the weight using the Franner, and it was 3 tons. So yeah, so this took over 4 hours to remove, and luckily for us, that was the first shut, the first hydrant replacement for the stage 2. So we allowed plenty of time. So we planned for 5 hours of service interruption. So we notified the customers, And we finished it within time. We brought the scheme back, that section back online within time, but just barely. So that impacted about 80 customers. And just as I thought this issue was over, this is what I woke up to the next day. So this is at the same place. We've already, backfilled. It was good. So, well, I got a call from an operator at 6 in the morning. I was on site for that shut. So, and he said, Mo, there's a massive burst where you've replaced the hydrant. And I was like, no, I checked it out last night. It was good. It's been operational for at least over 12 hours. And he's like, no, I'm serious. And I said, okay, I'll go out. And so I went out, and this is what I saw. It's just like a water fountain. So then, obviously, we need to shut this section down, and we were going to impact the same customers that we actually impacted the previous day. So for these events, we had contingencies in place, so we knew which customers were going to be impacted. So we dropped the letters off immediately. We updated the customers on the social media network, and we actually offered the customers places to shower. So we booked hotel rooms where there's water, and if they really asked for it, then then we would send them there. And that was 7 in the morning, mind you. Remember the first question I asked? They would have been getting ready for work, and yeah. So this is one of the unplanned bursts that was caused by these assets. And here's another one. This is the valve, and this is our water main, and there's another main coming through here, and this is a T-piece junction. Yeah, this is a T-piece junction. So this is not the only site that we came across like this. There were plenty of them, but this is a special one though. Because when we first started, I was on site for this as well. When we first started, we knew there were going to be power cables all around. So as a safety control measure, we used the vacuum excavator instead of using the bucket excavator. And also, we potholed first to find out where exactly the power cables would be, and then, we just removed the swale using the excavator. And once it's all excavated, what we found was the 3 high voltage cables were already damaged, which wasn't done by us, by the way. I think this is the culprit, though. This white one is an NBN conduit. Well, so the outer insulation was already peeled off, but they still had inner insulation, but it's still, water and electricity doesn't mix well, and it's a huge safety risk for us. So we stopped the work immediately, rang BHP. BHP runs the power for Newman, by the way. So, we've already got a working relationship with them because we had to get permits, to actually dig and do anything around there. So I've already got a relationship with BHP supervisor for electrical. So he came out straight away, and he said he'll get to it, and he fixed it. This is after fixing. So these are the black ones are the wraps that they put around the pipes. And we continued doing the work. Obviously, we had controls in place, like we used timber boards to actually segregate the area. So that's the most we can do, pretty much. So, like, for example, this section, they would have laid everything within a single trench. And can you find a valve here?
I can see the stems sticking out.
Yeah, so this is all you can see. And it's a small valve, it's not like a 300 diameter valve or anything. And you can see a pipe section still there. So there's a pipe going through, and it's a straight piece. So typically, you wouldn't have a thrust block on a straight piece. We would find something like, not exactly like this, but we would find a thrust block at a band or something to prevent the water pressure from pushing the valves out, but not like this. So these are just some of the examples, the challenges that we came across. So during the delivery of this project, we implemented a number of strategies to improve customer engagement as well. So many people in town, in Newman, they're shift workers. Some of them do night shifts, day shifts. So we made sure that they are aware in advance of the noisy works that's going to be taking place around their places, and we dropped off earplugs if they wanted. And we also provided bottled water to customers that requested. And on the ground, whenever I'm on site, I would personally visit, like doorknob the impacted the area, the customers within that impacted area to actually see whether they're happy with how we're doing. You know, all the restoration works are fine, because sometimes we're essentially digging up their driveways and stuff. So during the interruptions, like I've already mentioned, that we provided places for people to shower if we've gone over a certain period. And in fact, after the first after the delivery of the stage one, which was the whole entire town shut, we actually organized a community barbecue for the whole town, and our regional manager actually cooked the barbecue and fed the whole town to, thank the residents for putting up with us, by shutting the whole town down. And we proactively managed engage the customers using social network. So a town like that, Newman, they've got like a community Facebook page, and by using that page, we were able to directly engage with the customers and update them with the progress. Like if there's an unplanned burst, we would tell them that, oh, there's an unplanned burst, and we'll be fixing, it'll be back online in about 2 hours. So during this whole delivery work, we found out that the customers were more forgiving of the bursts and interruptions to the water service if they are well informed. And that was one of the big lessons we learned. So as the result of our work, we received really good recognition and feedback from the key customers and stakeholders, like the Shire, VHP, and these are just a few positive articles. So, regardless of the challenges, we delivered this project successfully without any safety incidents and with minimal customer impact. It was an overwhelming success, and ultimately, by project completion, we improved our relationship with the town. So to finish up, I'd like to leave you with a quote by Richard Branson. The key is to set realistic customer expectations and then not to just meet them, but to exceed them. And I think we achieved that with the project. Thank you.